Welcome back to my series on self-hosting. So we want to take a little bit of a different turn today, and we want to talk about self-hosting to infinity and beyond. The last time we talked about IPv4 self-hosting and mainly using NginX Reverse Proxy Manager, we referred to that as the secret sauce of self-hosting. NginX Proxy Manager allows more than one service to share a single IPv4 ISP-granted WAN address on your router, and that's how we pulled that off. So there are easier ways to self-host. One of those ways is you could purchase multiple IPv4 addresses from your ISP if you have a router that can manage multiple WAN addresses. And in that way you could have one WAN address that would go to every self-hosted application. But we're going to talk about IPv6 and how to self-host with IPv6. IPv6, how's it different? Okay, so IPv4 has 32-bit address space consisting of 4 8-bit numbers. So typically 1.2.3.4, each being a number from 0 to 255. And therefore, IPv4 has a total number of unique addresses at 4,294,967,296. Sounds like a really big number. IPv4 uses NAT private address space in the 10 range, in the 172.16 range, and in the 192.168 range to allow many computers to share one ISP-granted IPv4 address on each of your private networks. So that really does a good job in terms of preserving unique address space on the WAN. So IPv6 has a 128-bit address space consisting of 16-bit numbers, each being a number from 0 to 65,535. And IPv6 has a total of, and I'm not even going to try to read that number, just let us say that it's at least a large enough number to provide an address for every grain of sand everywhere on Earth, and that probably still isn't a big enough number. But that's the number of unique address spaces that IPv6 offers. So let's review what we did in IPv4 self-hosted networks. Well, basically, up at our DNS service provider, we had a DDNS, a dynamic DNS A record, and then we had a whole bunch of CNAME records that pointed to the same address, but since they pointed to different address or different service names, different subdomains, they were able to go to different services with the aid of an NginX Reverse Proxy Manager, or any reverse proxy manager for that matter. And basically all we did was we forwarded port 80 and 443 onto that system hosting NginX Proxy Manager, and an NginX Proxy Manager acted as a lookup directory to then point to our other IPv4 services. And if we had additional ports required for a self-hosted application, we would port forward those ports on your router to the particular system that needed those ports. So what we want to talk about today is we want to talk about an IPv6, IPv4 hybrid network. So normally both protocols can reside on the same network. They're like two languages, and they don't communicate with each other, but they can coexist. So it's like if you walked in a room and people were speaking two different languages, one group that is speaking the one language might not be able to understand the second group, and vice versa. So in the case of IPv6, we may have all of our IPv4 addresses, our dynamic DNS A record, or multiple A records, or CNAME records. But in the case of IPv6, we're going to have these things called quad A records, AAAA records. And we have to create a new name because we can't use the same name. So in the case of my services, I consider kind of a best practice to say whatever the name of the service is, -v6, just to remind me it was a v6. So for example, on my web server, it's www-v6.scotti-byte.com. And if you access that, you'll actually be able to reach my address you'll be able to reach my web server at that address. Now, down here, right above the router, we've got your IPv4 WAN address, which in this case was 73.206.54.10. Over here in red, though, I have the Internet Service Provider issued IPv6 global address range. And that range is anywhere between 2 to the 56 to 2 to the 64th power, depending upon the Internet Service Provider. And that's roughly 18 quintillion addresses for your personal use. Every single customer of an Internet Service Provider has 18 quintillion addresses that they can use, which are their own private addresses. So we don't have any need for port forwarding anymore because we have those unique addresses. So the only other way I changed this diagram down here was in the case of the web server, I have my IPv4 address, but down here I have my global IPv6 address for that. And then over here I have a discourse server, and that would be its IPv4 address, which would be reachable by the reverse proxy only. But the IPv6 address is directly reachable over the internet using the IPv6 address. So why IPv6? Isn't IPv4 with NAT private address spaces sufficient? Well, when IANA, which is the Internet Assigned Numbers Authority, first assigned addresses in the early days of the internet, some organizations got really excessively large address blocks. And two organizations in particular that got really large address blocks were Digital Equipment Corporation and HP. They both got Class A address ranges, and each of them had nearly 17 million addresses in that range. That's a Class A address range is basically like 15.0.0.0 with a subnet mask of 8, the first number. And so that was a huge number of addresses. Well, HP acquired Digital Equipment Corporation way back when. They merged. So now Hewlett-Packard is basically the largest holder of IPv4 addresses on the planet at more than 33 million addresses. So today we're basically out of addresses. It kind of depends on where you live in the world, but there's some locations that just aren't granting any more IPv4 addresses at all. So although IPv6 is in wide use on the public internet, most home users don't make use of it and aren't even really aware that it's out there. So eventually IPv6 or IPv4 rather will be retired. We're not sure when that will be, but it will be someday. How does IPv6 work? Well, IPv4 and IPv6, as I already mentioned, can coexist on the same network, although they don't communicate with each other. They're unique languages. Linux has supported IPv6 since 1996, and Windows started supporting IPv6 back in 2009 with Windows Vista. With IPv6, each host interface has a link local address and multiple routable addresses. These addresses are the global unicast address, which is routable on the internet, the unique local address, which is similar to the IPv4 private address that you have on a NAT, and finally an Anycast address, which is the same unicast address on multiple devices. With IPv6, DHCP is unnecessary because of stateless auto configuration. That's a mechanism whereby routers send out router advertisements that contain the upper 64 bits of an IPv6 address, and hosts generate the lower 64 bits themselves, and that completes an entire 128-bit IPv6 address. So the bottom 64 bits of an address, of an IPv6 address, are generated from the MAC address, the hardware address of the machine connecting to it, by flipping a bit and adding the bits FF and EE in the middle. So the MAC address that I've got here results in this sort of an IPv6 lower address, the lower 64 bits, which is the interface identifier. And also you notice that the numbers in an IPv6 address are delimited by colons rather than dots, and there are 8 of them. So this lower address only has 4 of them here. So IPv6 operates differently than IPv4 on a LAN. On a local area network, IPv6 does not use broadcast message delivery like IPv4 does. Instead, it has increased efficiency by using only what are called unicast, multicast, and anycast. So what do I need to run IPv6? Well, first of all, your ISP must support IPv6, and I might add that most do today. It would be very unusual to find an internet service provider not supporting IPv6. Secondly, your router must support IPv6, and it is possible that your router does not support IPv6. And then you must define an IPv6 prefix delegation on your router wide area network interface. And then you must enable IPv6 on each LAN or VLAN where you want to use your IPv6. All right, so let's configure IPv6 on the WAN interface. So all routers are different, unfortunately. This is a very brand-specific type setting. I use a Ubiquiti Unify router, and on Ubiquiti Unify, it's done in one particular way. And secondly, the thing you're going to need is you're also going to need to know your ISP's prefix delegation size. So I have Xfinity, and where I am with Xfinity, their prefix delegation size is 56 bits. And it'll generally be anywhere between 56 to 64 bits. Don't worry, you'll still get roughly 18 trillion unique IPv6 addresses for use on your local LAN. And I want to hear from anybody in the comments if they've used all 18 trillion addresses or plan to, or 18 quintillion, excuse me. So on my Unify router, we've got down here this area for IPv4. It says connection type is using DHCP. Well, that's standard. That would have been there before. But in this IPv6 section, I change it to using DHCPv6. That basically says allow the addresses to flow down from the prefix delegation. And it says what size is that prefix delegation. Here you can see I have it set to 56 bits. And that's all there is to it in terms of enabling it for your WAN address. So the next thing we have to do is that once it's enabled on the wide area network on your router, we have to enable it on your LAN. So this also differs per router brand and model. You're going to enable the prefix delegation to the LAN, and you're going to enable IPv6 router advertisement. So the way this looks is like this. You'll see that I have interface type, prefix delegation. Prior to me setting it, it was set to none. And then I have 2 WAN adapters, so I'm doing this for WAN, the regular WAN adapter, as opposed to WAN 2. And then I have the checkbox enabled for enabling IPv6 router advertisement. And then router advertisement priority, well, I have it set as high only because I don't really know what medium or low do, but I have it set to high. And then the DHCP address range, well, this is some kind of a default that I noticed out there. It's a pretty broad range. I don't really. It probably limits it down to several billion addresses. So I'm probably not going to have to broaden that range at least until next week. Depends on how much self-hosting I do. So how do you know IPv6 is working? Well, you'll want to do an ifconfig in Linux or an ipconfig in Windows. And before IPv6 is enabled on the LAN, that command will look like this, at least in Linux it does. There's my IPv4 address, 172.16.1.255, And here is what's called a link local address, which is kind of like a NAT address for IPv6. And the reason we're not seeing the global address is because we haven't yet enabled it on the LAN, but we did enable it on the WAN. So all this does is allow IPv6 nodes on the same LAN to talk to each other. And link local addresses are always preceded with an FE80. That's just the standard. And then, of course, we have the MAC address of the adapter. So after IPv6 is enabled on the LAN, we then have 3 lines for IPv6. The first line you see here, which is really, really long, is the IPv6 global address on the internet for this particular node. And remember, everything on your LAN has a global address, an address reachable from anywhere in the world, basically. And then finally, or next, we have the FE80 address, the link local address again. And then finally, we have another one that starts with the same address, 2601, but it's a little bit shorter. And this address is just called an Anycast address. It's the address that it uses to do broadcast management for node existence and node status on the local network. Okay, so how do I use IPv6? Since every system on the LAN already has a global address in IPv6, there's no reason for port forwarding rules, which were designed for network address translation. Okay, so we don't need port forwarding. This, however, does not mean that every system on your LAN is exposed to the internet. That's a good thing. The router is still a firewall, and the firewall's main function is to control inbound access from the internet. So you must create a router firewall WAN in rule to make a IPv6 system accessible from the internet. So what does an IPv6 rule look like? Well, again, this differs by router or model. And here's an example of my IPv6 router rules on my WAN in connection. So I've got basically 3 of them or 4 of them here that are at note. I have one for my PHP bulletin board, another for my web server, another for my discourse server, and another for my Jitsi server. And over here, they don't just put addresses in, but rather they put these things called groups. Groups are separately managed out here, but you could have more than one address in a group if you like. But in this particular case, I have one IPv6 address for my PHP bulletin board server, and that's its group name, one address in the web server group, one address in the discourse server group, and one address in the Jitsi server IPv6 group. So I just wanted to make it easy. And then web ports is just ports 80 and 443, because those are the 2 ports I want to actually open down to the server. Not all ports, but just the ports needed for that application. And then all the way at the bottom here, I have Jitsi ports enabled for the Jitsi server. Why? Because Jitsi uses ports in addition to 80 and 443. Okay, why is IPv6 better for self-hosting? Well, IPv4 port forwarding uses one WAN address, so if you need the same port for more than one application, you must change the port number that the application uses, because only that one port can only be forwarded to one system inside your network. And since IPv6 has a unique IPv6 global address for every single server instance on your network, every system on your network, the same port can be used for every server if needed, because they're all unique servers. It's like having an unlimited number of wide area network devices, which is exactly what it is. So the downsides. Well, despite the fact that IPv4 addresses are exhausted in many parts of the world, notably places like some parts of Asia and some parts of Western Europe, IPv6 has been kind of slow for adoption. So we don't have IPv6 up and running at all the way down to the user level in a lot of cases. Although ISPs have it, it's not necessarily configured for end users. And in point in fact, when you go look at your router, if you notice that IPv6 is turned off, your ISP may be providing it to you, but unless you've turned it on your router and also turned it on the LAN, you're not going to be able to see IPv6 systems out on the internet. So ideally, configure both an IPv4 and an IPv6 address for key applications. That's just a good practice if you're going to create things and you want them to be available for both groups of folks. Because ultimately, there will be somebody on the internet that only has an IPv6 address because they weren't able to be granted an IPv4 address. So, in summary, IPv6 is a good thing to learn. Very important. It has a lot of new technology. It's very attractive for several reasons. In some parts of the world, IPv6 may be the only option at some point, and even now, although that's a little hazy to me. And IPv4 may go away, but I don't think in our lifetimes. So offering services in IPv6 is easier because there's no need for reverse proxy, and there's no need for network address translation. There's no NAT. And I wrote a series here, I guess about a year ago or so, called The Joys of IPv6. It's a 3-part blog, and this is the link to the blog down there. I'll try to put it in the show notes as well. And it goes into an in-depth, very technical discussion of IPv6, which I wrote. Anyway, that's all for today. And if you made it to this point, thank you so much. And please subscribe and like, and we'll see you next time.